Hi everyone, welcome to my channel. I am Professionals here. So in this video, I am demonstrate how to conduct multinomial logistic regression using SPSS. Multinomial logistic regression is used when the dependent variable contains three or more categories without a natural order. So we have three categories in our dependent variable. You can see plan choice. So we coded the variable as 0 equal to basic plan, 1 equal to standard plan, and 2 equal to premium. As well, in our example, we have data set of 240 students. The dependent variable is plan choice and three categories: basic, standard, and premium. So we will examine whether usage hours, which is basically our scale variable, and students categorical variable, as this one is factor usage hours. This is COVID. So we will put as per in our data labels. So we will examine whether usage hours and student status significantly predict which plan a person selects. So I will explain how to choose and change the reference category, evaluate overall model fit, interpret pseudo R-scale and classification policy, and understand regression coefficients or ratios, confidence interval. So before performing the analysis, we need to see the research question, threshold values, and the 7 steps for applying the multinomial logistic regression aspects. So we go to our formal presentation. We see multinomial logistic regression in SPSS. We are predicting one nominal outcome with three. So we have three nominal outcomes: basic, standard, and median. So we will compare one with others. So our research question is to usage hours and student status predict whether a customer uses the basic, standard, or premium. So one nominal outcome creates multiple logics. In this way, modern unordered categories, and we are going to do reference basic and first category. So in this way, SPSS will automatically calculate basic as a reference category with standard, and then basic with premium. As well, nominal coding independence and stable estimation come first. So we will also ensure the 7 conditions before implementation. Nominal outcome, certainly dependent variable should be nominal outcome, variable mutually exclusive and agnostic category. Independent cases, reference coding, linearity of logics, no multicollinearity, no separation and basic category counts. So these are also threshold values to see whether the model fit with acceptance and rejection of such hypothesis. So now we come back to our data set and perform the multinomial logistic regression to SPSS. We go to SPSS data set and we then click on analyze and regression and then click on multinomial logistic regression. So in this way we put the dependent variable as pledge choice our dependent, and student status is our factor because this is categorical, and the usage hours is a scale variable. So we'll put the COVID. Now we come to model. We don't need to do anything here. Statistics, we know need pseudo R-scale, step summary, model fitting, information criteria. So these are automatically selected in SPSS. So further we need goodness of fit and a classification table. Then click on continue. Criteria we're using, we have no issue here. Options, no issue here. Save, we need estimated response. Probabilities, predicted category, probability, actual category. And bootstrap, everything is good here. Now we are going to select reference category because we are going to select basic and first category. So we put this first category and we click on continue and we click on OK. So in this way we have get the analysis of multinomial logistic regression in this case. So you can see case processing summary, plan choice. There were 62 samples for basic, standard 102, and premium 76. And student status no 142 and with yes no. So there was total valid 240 responses and there is no mistake given. So next we come to our model fitting information. So the final model was statistically significant because the chi-square value is 50.306 where the degree of freedom 4 and the value of p is significant because the value of p is lower than 0.05. Therefore, we can simply say that usage hours and student status collectively improve the prediction of land choice compared with the intercepted one. So next we see the goodness of fit and the Pearson and Lyon's goodness of fit test were non-significant. You can see p values higher than 0.05. So in this way, this generally indicates an acceptable model fit. Okay, so we come to next. So we can see here C to R square. So in case of three recommended threshold values, we can see first one is explained 0.189, which is 18.9% of variance in dependent variable, and our dependent variable is plan choice. So it means we can also say that the model explained 21.4% of the variance in plan choice according to this threshold. And we also see the next table, likelihood ratio test. You can see here both predictors because using hours and student status were independent variables, so these were predictor variables. So both predictors made significant contribution to the usage hours produced a likelihood ratio square of 18.526 and p value is also less than 0.05. While student status has chi-square value 31.225 and p value also less than 0.0. So we can also say F standard versus basic. Now we go to next table, which is a very important table, parameter estimates, where we compare the reference category with the other category. So parameter estimates with plan choice we are comparing because basic is our reference category, so we compare first basic with standard and basic with medium. So for standard versus basic, usage hours had a significant positive effect. You can see the beta value is positive 0.056 and also a p value is less than 0.05. So with an odds ratio of 1.05 and the p value is equal to 0.003, which is lower than 0.05. So each 1 unit increase in usage hours increase the odds of using the standard rather than the basic plan. So by approximately 5.8%. So we also see the next. Now we see that student status. Student status was also significant for standard versus basic. You can see minus 1.131 beta value and the p value is also significant because it is lower than 0.0. So non-students had a odds ratio of 0.323 compared with students p value to this one. So this means that non-students had approximately 67.7% lower odds of using standard rather than basic plan. Okay, so we see the next comparison between basic to premium. So for premium and basic, usage hours was statistical significant. You can also see usage hours, beta value is 0.081 and the p value is less than 0.0, and the odds ratio is 1.084 and the p value already less. So it means each 1 unit increase in usage hours increase the odds of choosing premium plan rather than the basic by approximately 8.4%. So we can also see here the student status was not significant because the value of P is greater than 0.05. And in this case, because this is the case in case of basic with premium, so basic and the odds ratio is also defined here 1.916, this one, and equal to, because the p value is higher than 0.05, its confidence interval also included one. You see the difference between lower and upper boundary, so one comes under between both values. So therefore, there was insufficient evidence that student status distinguished premium from basic after control for usage. So we also checked the model correctly classified 54.2% of concepts, and you can see here 54.2% overall percent. So classification accuracy was 33.9% for basic, you can see here, and 60.8% for standard and 61.8% for pre. So in this way, we just applied the basic as a reference with standard and the pre as per our research question and the category. You can see here. We just check the logic 1 standard versus basic and logic 2 premium versus basic. So if you want to see also the last category as premium with basic and premium with standard, so we can also do in this way. We come back to our SPSS data and can analyze and regression, multinomial regression. Everything is same. Just need to ensure first we selected the first category which was basic. Now we select the last category which is premium. So now we are comparing premium plan with basic and standard. Now we continue and so these are the case processing summary. Basic 62, standard, because these are the same results and we have explained above. And you can see model fit information I-square 50.306, which is also significant. And you can also see the goodness of it. Both are insignificant because there is good model fit. And now we come down likelihood ratio test. So effect, usage hours, student status, so I-square value, both are significant. It means both are in student plan choice. The most important findings are here because this table has been changed from the previous. Okay, now let's get this table. So we can simply say here basic versus premium. Basic versus premium usage hours had a statistical significant negative impact on plan choice. You can see the usage hours value is minus 0.081 and the significant level is 0.00, which is lower than 0.05. So it means there is a statistical negative impact of usage hours on plan choice. And the odds ratio of 0.922 and the p-value positive less than 0.05. This means that each additional usage hour decreased the odds of selecting basic rather than premium plan by approximately 7.5% ratio. In other words, we can simply say that higher usage hours were associated with the greater likelihood of choosing premium plan and the others. So, when we come to student status equal to 0, student status equal to 1, we also see that student status was not significantly associated with the odd ratio and the plan. So, you can see here the value is minus 0.650 and the significant level is 0.109, which is higher than 0.05. So, in this case, the relationship is not. It means student status did not significantly create difference between these two plans in basic and premium. Okay, now we see the standard with reference to. So in this case, usage hours was not statistically significant. Why? Because there is a value negative 0.025 and the p-value is higher than 0.05. So, and the odds ratio is 0.975. Therefore, usage hours did not significantly create difference standard from premium. However, student status was significantly different with an odd ratio of 0.168 and the p-value is less than 0.05. So compared with students non-student at approximately 3%, lower odds of choosing standard rather than premium, and equivalently, non-students were approximately 5.95 times more likely to choose the premium rather than standard. Overall, higher usage hours significantly distinguished premium from basic, while student status significantly distinguished premium from standard. So in this way, we perform the multinomial logistic regression in SPSS. So if you find my video helpful, please subscribe to my channel and press the bell